All right, we're going to begin with a speed drill today. So open up your speed drill booklets to speed test number 5. A lot like the last speed test we just had, some add, subtract, multiply, and divide. You're going to have 4.5 minutes for this speed test. Like the last one, you don't have to work in order. Okay, so go in the order that works best for you. 4.5 minutes, and you may begin. One more minute. Stop. All right. right, pencils off your desks. Pencils off your desks. Have out a pen and exchange with the person behind you. Person in the back, bring yours to the front. Exchange with the person behind you. Person in the back, bring yours to the front. Again, pencils off your desks and pens out. Pencils off your desk, pens out. Sign your name as the grader. Next to where it says speed test 6, there at the bottom of speed test 5. Speed drill, it says speed test, whatever. Once again, these are 10 points each, like last time. Top row going across. Your answers are 16,232. 16,232. Number 2 is 543. 543. Number 3, 10,865. 10,865. Number 4, is 5,478. 5,478. And number 5 was 880,488. 880,488. The next row going across, for number 6, we should have gotten 28. 28. That was a little harder because your 4 couldn't really be the estimator. It didn't work too well, as is typically the case when the second digit in the divisor is a 4, 5, or 6. Just kind of messes with stuff. For number 7, added up to 23,200. 23,200. And number 8 is 218,400. 218,400. Those 3 I would have saved for last. To me, those 3 problems were harder than the others on here. Number 9 wasn't that bad. You get a nice easy answer of 37. 37. And number 10 was maybe one of the easiest ones on here if you think of 6 quarters. 25.50, 75 $1, $1.25, $1.50. And there's your $1.50 or 150 rather for your answer on number 10. No decimal in it, 150. So hopefully you noticed that the last problem was an easy one and went ahead and did that one real quick. 10 points each. Figure the total number wrong times 10, subtract from 100. Hold on just a second. Yes, ma'am?
What was it again?
Number 4 was 5,478. Yes, ma'am? Make sure we're listening really well, please, as we're grading. I know it's a Friday and we're tired and we're looking forward to Labor Day, but stay focused. 808. Peace be still. 880,488. Now, put the score, if you would, in the score blank. Also, flip to the score page, that first page of the booklet. Put the score there as well. And return to the owner. People in the front, take them to the back. Return to the owner. People in the front, take them to the back. Sam, make sure you get all that stuff kind of neatly under your desk or in the book rack under the desk, so that way you don't trip, fall, turn ankle, because you still have to run your lap to pee today, even if you really are. I'm just kidding. All right, go and return to the owner. All right, we had a couple hundreds last time. I'm curious if we had any hundreds this time. All right, we added one more. How about 90s? 90s. We didn't have any 90s last exercise. All right, how about 80s? Ah, good. So some of our 70s became 80s. All right. So hopefully, how many just did flat out better? This was better than the last speed drill. All right, several of you. Good. All right. Pass those forward. I just want to work on speed and accuracy. Pass those forward, if you would, please, as you're passing them forward. As the camera shakes. As you're passing them forward, if you would, go ahead and open up your textbooks to page 33. Page 33 in your textbooks. Page 33 in your textbooks. And you did the homework, numbers 9 through 19. So your book's open to page 33. You did 9 through 19. Yesterday I began working on some word problems. Curious to see how we did on those. Also some different things with exponents and order of operations. Continue to practice with all of that. Let's see how we did with those. Go ahead and read word problem number 9 for us, if you would, Sam.
Lakeview Christian School sold 1,245 cases of candy bars. This year's candy sale. The year before, they sold 1,440 cases of candy bars. How many fewer cases of candy bars did they sell this year than the last 2 years?
All right, so as we read the problem, the first thing we notice is, shoot, that's a lot of candy, right? But last year, they did better, didn't they? That's the other thing we noticed. Last year was a better year than this year. So, how many fewer cases? What do we have to do to figure out how many fewer, Sam? Subtract. If we add, it would give us the total number of cases. That's not what we're after. If we multiply, whoo, that's going to give us a huge number. That's not what we're after. And division, no, we're after subtraction. How many subtracted on number 9? And Sam, what's the answer?
205.
Ooh, careful on your borrowing, Bryson.
190.
195 fewer cases this year than last year. So not too much worse. A little worse, but not terrible. Number 10. Go ahead and read that for us if you would, Paige.
Anthony financed the car for $14,976
Dollars.
He is paying for the car in 48 equal monthly payments. How much is his car payment each month?
All right, 48 payments. That's pretty ambitious. I usually do the 60 month when I've financed vehicles. What do we have to do? If they give us the total amount he's got to pay, and they say he's going to break it up into 48 payments, what do we have to do? Divide. How many realize you've got to divide? Now, if every payment was for one thing, that's an expensive car. If every payment's $14,000, then we would multiply, right? But here we're going to divide, and what did you get for your answer?
312.
How many have $312 for your answer? That's a pretty significant car payment, at least to me. I don't know, I drive cheap cars. $312 a month is correct. Number 11, go ahead and read that for us if you would, Griffin.
The Newton Corporation has a profit of $174,048 to divide evenly among 518 employees. How much will each employee receive?
Now this time they kind of tell you what to do because they use that word,
Divide.
And so when you divide it, how much does each employee get? What is their dividend at the end of the...
$336.
$336. How many had that answer for number 11? Questions on the word problems? Any questions on the word problems? All right, let's take a look at number 12, rewriting with exponents, Elaine.
12 is 2 cubed times 3.
Good, 2 cubed times 3. Number 13, Jalen.
2 squared times 5 times 11.
Excellent job. 2 squared times 5 times 11. Number 14, simplifying with order of operations. They've got some subtraction, they've got some addition, they've got a division, they've got an exponent. What do we do first, class? Exponent. So Bryson, the 3 squared, 9. Then we've got to do what, Luciana?
Multiply or divide.
Multiply, divide. In this case, divide. The 9 divided by 9 gives us a
3.
9 divided by 9?
1.
1. And then finally we can do all the subtraction and addition and all that jazz to get what final answer, Corey?
20.
20 for number 14. Number 15. We've got some parentheses we've got to take care of to get what, Ben?
3.
And then we've got to take care of the division before we add. So when we do the division, we get what, Kirsten? 9. And then we add at the very end, Michael, to get 36 for our answer. Number 16, how many grouping symbols do we see, class? 2. Obviously the parentheses at the end, but also, class, the fraction bar. Tells us to group the top, group the bottom first. When we group the top, Jalen, we've got some bigger numbers there. What do we get? The 27 plus 48? I'm sorry?
75.
75. And then in the bottom, we've got a 42 minus 27. That comes out to what?
15.
15. So when we do our division, because that's what a fraction bar tells us to do, we can divide 75 by 15 to get 5. Then we're going to hold off on the addition and add 5 times. Of course, in parentheses, it said 1 plus 4 class. 5. So we're going to multiply the 5 times 5. Do not add here. Multiply the 5 times 5, Ben.
25.
25 is correct. And then we're going to finally do the addition to end with what answer?
30.
30, there we go. How many have 30 for number 16? How many got all 3 of the order of operations problems correct? All right, any questions on those? Number 17, true or false? The prime factorization of 18 is 2 times 2 times 3. Paige?
12.
It should be a 12 right there, shouldn't it? 2 times 2 times 3 is 12, not 18. Number 18, the number 2 is the only even prime number, Elaine.
True.
True. Number 19. The number 87 is prime. What say you, Kirsten?
Composite.
It's composite. What factor should we see from our list of memorized division hints in the number 87? Because it's not in any of our times tables, right? How do we know it's composite? What's in 27? Or 87, rather? Ooh, so you just guessed it was composite?
No, I didn't.
Oh, well, but then if you knew it was composite, you had to know there's a factor in it besides 1 and 87. Jalen?
3.
There's a 3. 8 and 7 adds up to 15, right? So if 3 can go into 15, it's not even. So we know it's not a 2 or a 4 or a 6 or a 10. We know it doesn't end in 5 or 0, so we know it's not a 5. But possibly the 9 or the 3 could work, and sure enough, the 3 does. So that's how we know it is composite. Questions at all on the homework? Any questions on the homework? All right, take a look, if you would, please, on page 32, right across the page. We were working through these word problems. We did not get to 20 or 21. At your seats, I want you to work on number 20. At your seats, do number 20. Give you about a minute and a half to work on it, and then we'll go over it together. Word problem 20 on page 32. It was 19 for the Taylors and the Green Kids, and how much money they spent. Each one sells for this much. So they sell one, they get that much. They sell two, they get that much again. They have 37, what you do. Right. Yeah, that's what I wasn't working out. All right. Number 20 says electric connection has 37 dishwashers at an average selling price of $489 each. So if they sell just one dishwasher, class, how much is that? $489. If they sell two dishwashers, it's going to be another $489, which is like somewhere near $1,000, right? What do we need to do if they got 37, class? Multiply. And when we multiply the 37 times the 489, what's the exact dollar figure, Corey?
16,793.
Some carrying or something went askew there. Michael? 18,093 is what we should have had for our answer. So if you didn't get that, you're going to need this answer for the next problem. So make sure you got this correct answer here. But then it says round to the nearest $100. Corey, for redemption, if I round this answer to the nearest $100,
18,100.
$18,100. Remember, this little symbol here means approximately equal to. So this is the actual number. This is a good rounded number. If somebody were to say, how much you plan to make? Now, personally, if somebody asked me, how much money do you plan to make off these dishwashers? I would say 18,000, right? I'm not going $18,093. No, just 18,000 bucks, 18 grand, right? So probably a better way to express it. Now, for each dishwasher, look at problem 21. Each dishwasher cost the company how much, class? Look at problem 21. Each dishwasher cost how much? $295. Remember, the company doesn't get these dishwashers for free. They buy the dishwashers and then they sell the dishwashers. They buy them for $295. They sell them, class, for $489. So if we were to take what they sell minus what it cost them in the first place, that's called profit. That's money that you make, right? Profit is a good thing, okay? So there's a couple ways you could go about this, but at your seats, my question is, how much profit did they make if they sold all 37 of these things? There's two different ways you could go. At your seats, I want you to see if you can figure out one of the two ways to find what is their profit if they sell all 37 of these dishwashers. How much money are they actually making? Because that's not how much they're making. That's how much they, quote unquote, had in receipts, but they had to pay for the dishwashers in the first place. 37 dishwashers. Every one of them, on average, costs $295. I said there were a couple different ways you could approach the problem. I'm curious, Bryson, what did you decide to do? Do what? Divide what?
295, or 18,093 divided by 295.
Oh. No, that wouldn't work. Okay, I was like, I hadn't thought of trying that. No, that's why I didn't think of it. It wouldn't actually work. So no, that went, and it didn't work out very well, did it? No, I was like, the number seemed kind of strange. What are your thoughts, Paige? Adding what?
295 and 489.
Well, we wouldn't add, because they're paying out money and then they're getting in money, right? The money's not moving necessarily in the same direction. So no, we wouldn't do that. Elaine, what do you think?
I multiplied 295 by 37.
Okay, so what we're doing here, if we multiply 295 by 37, this is going to tell us, this is the cost of each one, right? But there's 37 of them. So one way to do it, I think this is probably the most natural way to approach it, is to say if they pay $295 per dishwasher, multiply that by 37, and my crummy book didn't actually tell me the number on this. So we've got to actually work it out. Class, do it with me really quick. 7 times 5.
35.
Carry the 3. 7 times 9 plus 3.
66.
66. Carry the 6. 7 times 2 plus 6.
20.
20. Don't forget the 0 to shift over because it's really a 30, but we're going to treat it like a 3. 3 times 5.
15.
Carry a 1. 3 times 9 plus 1.
28.
Carry a 2. 3 times 2 plus 2.
8.
8. All right, when we add it together, we end up with $10,915 worth of cost. So the company, Electric Connection or whatever, they shelled out $10,915 to get these dishwashers. By the time they all sold, they had made $18,093. Does that make sense? Which means they made more than they spent, which means they made a profit. But how do I figure out how much profit there was now, Bryson? Come back to you. Oh, Bryson, this is how much it cost them, right? So imagine, let's go small scale here. Let's suppose you're like, I got this. And you buy all the sodas at the senior snack cart. How much do they charge for sodas at the snack cart? 75 cents. Let's suppose you buy all their sodas. You now have all of them. You're sitting at a table with a mound of sodas around you. But instead of just giving them to classmates out of the goodness of your heart, you say, all right, y'all, I'll sell these to you for $1. They can't go to the senior snack cart because you bought all the sodas. And now, every single time you bought it for 75, you're selling it for $1. How much money are you making on every single soda? Bryson, what's $1 minus 75 cents? 25 cents. You're making 25 cents a soda, right? All right. So what we could do is you could take all the money you paid the seniors. Let's say you paid the seniors $70 to get all their sodas. But you turn around and you make, after you sell to all your classmates, you make, $100. Well, you're making money, right? You would take what you got from your classmates, or people, minus what you had to pay, wouldn't you? And it even does tell us here, helping us out, profit is found by subtracting the cost from the selling price. How many of them subtracted the $1,893 minus the $10,915? Ooh, do it now. Let's find out how much money they made. Again, this is not the only way to do it. This is one way to do it. And do we get $7,178? All right, it did say to round though, didn't it? It said round to the nearest 10. What would it be round to the nearest 10, Kirsten?
7,180.
Try that again. 7,000.
180.
There we go. $7,180 approximately. Did anyone think of a different way to approach it? Michael, what did you do?
I did that same exact thing first, but I think, can you average it?
It already is averaged. They already started you with average numbers. Here's the other thought. Every dishwasher, okay, look up this way. Pencils down, you don't need to be writing anything right now. Look up this way. Every dishwasher cost $2.95, correct? But they're gonna sell every dishwasher for how much, class?
$489.
$4.89. We could find, kind of like with Bryson, well, how much are we gonna make on each dishwasher? So each dishwasher, we're gonna make $194, right? If we're gonna make $194 on every single dishwasher, and there are 37 of them, that would also give you the same answer. So that's the other way you could do it. It doesn't really matter either way you go there, but that's what we should have gotten. All right, next thing, and then I want you to look at in your textbooks, flip back to page number 28. We talked about common factors a few days ago. We talked about factoring a few days ago. We led into prime factoring, but we started just by talking about factoring. And we said, for instance, if I had the number 12 and I wanted to factor it, I could say that 12 is equal to 1 times 12. 12 is also equal, class, to 2 times 6. Class, it's also equal to 3 times 4. There we go. So the factors of 12, you don't need to be doing anything right now. You need to be looking up this way. 1, 2, 3, 4, 6, 12. There's your factors. What about 18? What's the most easy way to factor an 8? Like Chloe, Timmy. Okay, let's go younger. Timmy would know the factors of 18. The first one at least. Bryson? Because he knows that 1 times anything is itself. There's another factor of 18 that Chloe has learned that Timmy has not. Kirsten? 2 times 9. Of course, there's one more as well. Jalen?
3 times 6.
3 times 6. So the factors of 18, of course, are, class, 1, 2, 3, 6, 9, 18. If we were to identify common factors, well, what's a factor in here that's common, class? 2 is common.
And
6 is common. I heard, let's see, 6 is down here. I heard 1, I heard 3. So we would say the common factors are 1, 2, 3, and 6, where 6 is what we call the greatest common factor. This is one way that you could find a greatest common factor. But there's a better way to find a greatest common factor, and we can use prime factors to do it. The first key in using prime factors to find a greatest common factor is, of course, to prime factor. How many like the division of primes, the upside down division? So you're like, I like that better than the other. Let's see, 1, 2, 3, 4. Looks like majority, okay? So I think 7 of you, 4 if you do the tree like I do. We'll use the division house here. Let's start by dividing 12, class, by 2. And then we get
6.
Divide it by 2. And then we get
3.
And since it's prime, we're done. 18, divide it by
2.
To get
9.
Divide it by
3.
To get
3.
All right, so here's what we're going to do. If we look at these, do you notice, class, that they both have a 2 in common? Do you also notice they both have a 3 in common? So I circle what I see that's common. Now, this 2 doesn't match that 3, so I don't circle that. What have I circled, class? I've circled 2 and I've circled 3. 6. That's my greatest common factor. So in finding a greatest common factor with prime factors, you'll prime factor the numbers and you'll circle matching pairs. You'll figure what did you circle, and that's it. Now you're not going to say 2 times 3 times 2 times 3. Hey, they got a common factor of 36. A factor can't be bigger than the number itself. No, just take, you circled a 2 for each of them and a 3 for each of them. Or you can ignore one of them and say, on this one I circled 2 and 3, 6 is the greatest common factor. Now on 12 and 18, let's be honest. If I just wrote the numbers on the board and said, hey, what's the biggest number that goes into both of them? Most of you would figure out 6 just fine, right? You don't even need to factor it. You could figure it out. But there will be numbers later that it might not be the case. For instance, if we had the number 48 and the number 64. Well, what number probably comes to mind the quickest, class?
2.
Oh, bigger number that comes to mind. 12 doesn't go in 64. 8. They're both on your 8 times tables, right? So thinking to your 8 times tables, probably we would think of 8. Let's prime factor here. Let's divide by
8.
prime factor. Divide by 2 to get 24. Remember, in prime factoring, division of primes, you have to use prime numbers only. That's why I like the tree better. Then we divide by 2 to get 12. Then we divide by 2 to get 6. Then we divide by 2 to get 3. I'm going to cheat and use the tree on this one. The most natural way to split 64, we memorized, is what times what?
8 times 8.
8 times 8. And each of the 8s can split into
2 and 4.
2 times 4. Scribble out the 8s now. And both of the 4s can factor into
2 times 2.
2 times 2. I'm going to scribble out the 4s here. So notice I've got 2, 2, 2, 2, 2, 2. Here I've got 2, 2, 2, 2, 3. All right, so what do they both have? They both have a lot of 2s. They both have how many 2s, class? 4. You say, but that one's got 6. Yeah, but this one doesn't have that many, right? If I decided to go around the class and take up a collection for the Mr. Nadaski Goes to Hawaii Fund, it's a worthy cause, believe me. And I said, okay, all of you, we're not going to have we can't have Griffin giving $100 and, Elaine is destitute and all she can give is 50 cents, because then there might be a tendency in my heart to favor Griffin because he gave more. So if we did take up a collection, you'd all have to give the exact same amount so there couldn't be any favoritism on my part, right? So if Elaine only has 50 cents, everybody in the class gives 50 cents. You can't give more than the poorest kid in the class. I don't know if she's the poorest kid in the class or not. We're just using that for illustration. I don't know that Griffin's loaded. Maybe he is. If he is, we're going to talk after. But anyway, you give what the poorest guy had. Well, in this case, this has 4 2s. That has more than 4, but they all have 4 2s. How about 3s? This one has, but that they don't share any 3s. So 2 to the 4th. 2 times 2 times 2 times 2, class. 16 is our greatest common factor. You find what do they both have, and you multiply all that together. Look at the numbers 20, 30, and 40. Now this one's kind of stupid easy, because all of you can look at the numbers and tell me what the greatest common factor is. 10, right? We already know that. But let's just say we didn't know that. And let's suppose we looked at the 20 and we said, hey, I can factor that into
2 times.
I could go 2 times 10, then the 10 factors into
2 times 5.
2 times 5. The 30 factors into
3 times 5.
I'm going to say 5 times 6. 6 factors into 2
2
times 3. Just for sake of illustration, 40 might factor into
2
2 times 20. And the 20 could factor into 2 times 10. The 10 factors into
2 times
2
5.
times 5. Of course, we could scribble out the composite numbers if we wanted. As we look at the numbers here, we notice, well, all of them have a 2. That one's got another 2. That one doesn't have another 2, right? That one's got a 3. The others don't have. Hey, they at least all have a 5. So if they all have a 2 and they all got a 5, there's nothing else that they all share. The greatest common factor, yes, is what we said it would be, class, 10, because that's 2 times 5. Do you see how to use prime factors to find a greatest common factor? Now look at the blue example box on the top of page 29, 16 and 24. Look at the way they break it down. They use the division of primes. They're at the top of page 20 or 29. They did 2, 2, 2, 2, whatever. For 16, they did 3, 2, 2, 2, 2. They start with a 3 on the 24. And notice when they listed them out numerically, they found, well, there's 2s that match, 2s that match, 2s that match, and the other numbers don't match. So what is 2 times 2 times 2, class? 8. So that's the greatest common factor. Look at 12, 18, and 42. 12 became, looking in your book, 2, 2, 3. 18 became 2, 3, 3. And 42 became 2, 3, 7. Well, they all got a 2, and they all got a 3. So the greatest common factor, class, is 6. Do we see how to find a greatest common factor by prime factoring? Because again, the bigger the numbers, sometimes it's just going to be hard. Not if you prime factor. Do the prime factoring and allow the matching primes to tell you the GCF. Any questions on that at all? All right. Turn your books then to page 30. Flip over to page 30. I want you to do, starting at the bottom of the page, going up to the top of page 31, just do numbers 1 through 6. Pages 30 to 31, do numbers 1 through 6. Prime factor first, even if you already know it. Like, most of you could look at the first 2 and get it in your head. For the practice sake, do the prime factoring. That way you can confirm that you've really got it. So even if you could do it in your head, that's great. Probably many of you can. Work out the prime factoring anyway, just to get the practice while the numbers are easy, because the harder numbers are coming. Let's practice while they're easy. 1 through 6. As always, once you finish, pencil down, look this way so I know that you're finished. Take about 30 seconds longer if you're still working. Several students here in the classroom finishing up on 1 through 6. I'm over here now. Oh, I thought I said look at me. All right, look this way. That's what I thought. I forgot my own words. What film?
Do that all the time.
What?
I do that all the time.
Video?
Say
You can go back and
something.
replay the video and we'll find out what I said. I don't know. I don't remember what I said.
Say something. My mom asked what, and I'm like, I don't even know.
My mouth was just moving. My brain was turned off.
Yeah.
All right, let's take a look at these. Number 30. They give you two numbers, 14 and 21. What were your prime factors of 14, Griffin? Number 1.
2 and 7.
2 times 7. And 21 was
3 times 7.
what matches?
The 7.
Just the 7. So we would say that the greatest common factor is
7.
7. Good. That easy. All right, let's look at the next one. Number 8. 8 and 24, rather, for number 2. 8, what are the prime factors, Elaine?
2 times 2 times 2.
And what about for 24?
2 times 2 times 2 times 3.
All right, what matches?
2, 2, 2.
3 2s. A 2, 2, 2, which gives us
8.
that's our greatest common factor. Looking at number 3, we got a 16 and we got a 32. And if you thought there were a lot of 2s last time, wow. 16, what are the prime factors, Ben?
8 and 2.
Well, those are prime factors, Ben. So we got to keep factoring the 8.
I did the factoring tree.
No, that's fine, but what did you end up with? Because you start with 2
Oh.
and 8. What did you end up with for 16?
2, 2, 2.
2, 2, 2, or
2, 2, 2, 2.
I'm about to say, should be a 2 to the 4th. In fact, I'll even write it with an exponent just because I'm lazy. How about the 32? What did you give me your prime factor at that one, Ben?
4 2s.
Shouldn't be 4 2s. That was 16. Should have had
5.
5 2s. Should have been 2 to the 5th. Well, if this has 4 2s and this has 5 2s, how many do they have in common, Ben?
4.
They have 4 in common. So 2 to the 4th, or
2 times 2 times 2 times 2.
which is
16.
16. That's our greatest common factor there for number 3. Number 4, a trick question. What are the prime factors of 5? Kirsten?
5.
5. For the next one, 10, what are its prime factors?
5 times 2.
5 times 2. So of course they have in common just a
5.
and that's our greatest common factor. For 12 and 20, what are the factors of 12, Michael? Prime factors of 12.
2, 2, 2.
Whoa. For 12?
I mean 2, 2, 3.
2, 2, 3, there we go. And then for 20?
2, 2, and 5.
All right, so what do they have in common?
2 and 2.
2 and 2, which is
4.
4. That's our greatest common factor. And then for number 6, we got a 15 and a 25. And let's see, Corey, 15's factors.
3 times 5.
And 25?
5 times 5.
All right, and what do they have in common?
5.
And that's all they got in common, so that's the greatest common factor. How many are all of these correct? All of them are right. Good. I want you now to go on to the odds 7 through 13. So do the rest of the odds. They're on page 31, 7 through 13. 7, 9, 11, 13. Question?
I was listening again. Why is the 8 crossed out?
The rule's just too hard to be practical. Like, I don't want to take a 3-digit number and try to see if 8 goes into it. So we just don't bother with the rule for 8. I don't care about 8. I don't know. I know it might seem really heartless of me, but I don't care. Aren't you glad you're at, wait, 7th isn't up there either. 7 doesn't really have a rule, that's why 7's not up there. Yeah. Like, I'm lazy, I want rules that are easy. I mean, 4 is already a bit of a pain once you get past like 48 for the last 2 digits, because like, we only memorized a 4 times 12. So if you saw, for instance, a 76 is the last 2 digits. Is that divisible by 4? I don't know. I'd have to figure it out, and that takes work, and the whole point of this is to save me work. So I really don't like the 4 rule very much, but 2 digits isn't too bad. 3 digits, nah, I ain't got time for that. The only thing is you can't use a 6, but you could use a 5 and get a 6, and then you could divide the 6 by. But you get a. Right, so what do they have in common? A pair of 5s, so it's GCF. There we go. So remember, only put prime numbers in the divisor side. Michael's finished with these 4. Tell you what, Michael, go ahead and hit the evens. If you finish early, hit the evens. Okay, so I had you do the odds first, but if you finish before I call time, work on the evens. Let's see if we can get those finished also. About 30 seconds more to work on these odd problems. All right, pencils down. Even if you're not finished with all of these, let's see how we did. For number 7, they gave us an 18 and a 27. What were your prime factors of 18, Sam?
18 was 2 times 3 times 7.
What about 27, Bryson?
3.
Look in your book. What did you do for number 7? You factored a 27. What were your prime factors?
3, 7. Yeah, that's different.
Okay, so let's do it now then, Bryson. Let's factor the 27. Let's just start with
Or 1.
whatever, well, no, prime number, but let's factor 27 in a way other than 1 and 27.
3, 9.
Times
9.
9. Okay, let's factor the 9.
3, 3.
There we go. Okay, so what are the prime factors of 27?
3.
Times,
3.
times.
3.
There we go. Okay, so what do they have in common now, Bryson?
They both have 3.
How many?
2.
They both have a pair of 3, so what's the greatest common factor?
3.
Times
3.
3. 3 times 3 is the greatest common factor, which is 9. There we go. 9's our greatest common factor. Number 9. Ooh, 125 and 150. What did you prime factor the 125 into, Luciana?
1 times 125.
I'm sorry?
1 times 125.
Well, that doesn't help me though. I need to be able to factor it another way. Jalen?
I did 25 times 6. No.
That would be 150. You did 125 times 6, or 25 times 6.
25 times 5.
And then what were the prime factors though? When you got it all said and done, what were your factors of 125? When you completed the prime factoring. Page.
5 times 5 times 5.
There we go. 5 times 5 times 5 is what we should have ended up with. How about for the 150 page?
5 times 5 times 3 times 2.
Okay. What do they have in common, page?
2 5.
A pair of 5s. 5 times 5, so the greatest common factor is?
25.
25. Looking at number 11, this time they gave us three numbers, 16, 20, and 28. What are the prime factors of 16 for redemption, Luciana?
2 times 8.
That's not prime, finish it. You gotta finish the factoring. 2 times
2.
times
2.
times
2.
2, there we go, 2 to the 4th, right? 4 2's. How about 20, the prime factors?
I didn't do it like that.
Oh, we've got to, that's what I look, hold on, we're gonna go a little past the bell today. All right, we've got to prime factor. That was the whole point of the lesson. So if you weren't paying attention, you've gotta stay with me, even on a Friday. We factor 2 times 10, and then we factor that into 2 times 5. Listen, on the homework, you have got to prime factor. What are the prime factors of 20, Luciana?
2 times 2 times 5.
There we go, 2 times 2 times 5. Okay, now for the 28, Luciana. How might we split up the 28?
2 times 14.
And then the 14 gets split into
2 times 7.
2 times 7. Okay, so what are the prime factors of 28?
2 times 2 times 7.
2 times 2 times 7. Now, what do all three numbers share?
A pair of 2.
They all have a pair of 2's, which means that 2 times 2 is the GCF, or in other words,
4.
4 is our greatest common factor. For number 13, we got a 36, a 54, and a 63. 36, you should have gotten 2 times 2 times 3 times 3. For 54, you should have gotten 2 times 3 times 3 times 3. And for 63, you should have gotten 3 times 3 times 7. What do they all have, class? A pair of 3's. This has 2 of them, this has 2 of them, this has 2 of them. So therefore, class, the greatest common factor is?
9.
9. Let me give you the answers very quickly to evens. Let's see. Number 8. Michael? 2. Number 10. Elaine?
8.
8. Number 12. Someone else get 12 besides those two? Ben?
6.
6. And number 14. Same 3. Y'all?
5.
Oh, 20. They have 2 2's and a 5 common. They got a lot common on number 14. Your homework for this evening, for the weekend, is to do page 33. Numbers 1 through 8. Page 33. The homework. Now look at page 33 real quick in your book. Look at page 33 in your textbook. See how there's the homework section you did the other day? And then at the bottom there's a chapter 1 review A. Do you see that? You're going to do 1 through 8 at the top, 1 through 9 at the bottom. That's your homework. Page 33, 1 through 8 at the top, 1 through 9 at the bottom. One more time. Page 33, 1 through 8 at the top, and 1 through 9 at the bottom. Have a great weekend. Enjoy your Labor Day off. We'll come back Tuesday. You are dismissed.